The next objective is to interpret a type 1 and type 2 error in context and give the consequences of each error. So we've learned that we can make a conclusion from a test, but sometimes we make a conclusion that is incorrect. And there's two types of mistakes that we can make. There's type 1 error and there's type 2 error. Type 1 error is when we reject, but we're wrong. We make an error. Type 2 error, which there's a typo there, I should say type 2 error. Type 2 error is when we fail to reject, but we're wrong. So type 1, we reject the null when the null is true. Type 2 error, we fail to reject when the alternative is true. So we should have rejected. Here is a little graphic to help see this. Here's the truth, and here's the conclusion based off the sample. Let's take a look at an example here. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. The producer will then perform a significance test using the hypotheses that the proportion is equal to 8% or it's greater than 8%, the proportion of blemished potatoes. So P is the true proportion of potatoes with blemishes in the given truckload. Describe type 1 and describe type 2 error. So the population is all the potatoes in the truck. They take a sample and they use that to determine is the proportion of all of the truckload have too many blemishes or is it okay to use them? So type 1 error is when we reject, but we made a mistake. So type 1, they have convincing evidence that more than 8% of the potatoes have blemishes, but in reality, there only are 8% blemished potatoes in the truckload. So there are some consequences. The consequence of type 1 error, this mistake means the potato chip producer sends away the truckload, but they could have used it because it was the acceptable amount of blemishes. So they're wasting time and they're losing money. Now let's take a look at what would type 2 error mean here. Type 2 error is when the producer doesn't find convincing evidence that more than 8% of the potatoes in the shipment have blemishes, when the true proportion actually is greater than 8%. So remember, type 2 error is when you fail to reject when you should have actually rejected. Again, type 2 error, they fail to reject, so they don't have convincing evidence that there's more than 8% blemished potatoes, but in reality, there are more than 8% blemished potatoes, which means they're going to make more potato chips with these blemished potatoes, which could lead to loss of returning customers. So again, if they have type 2 error, then they're going to make potato chips with blemished potatoes, which may end up having decreased sales in the future. So this is important to note to think about because you can pick different alpha levels. And so you have to consider the consequences of type 1 error or type 2 error before you pick your alpha level. Because in this situation, which error is worse for the company? I believe it's worse if they make the potato chips with blemished potatoes because they lose customer loyalty. Here, in type 1 error, the consequence is they send the truckload away to make sure they have a safe truckload. So they do lose some money, but you have to figure out what will be worse for the company, losing a little money here or losing the return of sales. So I think type 2 error is the bigger issue here. So type 1 error probability, the probability of making type 1 error is whatever your alpha level is. So If your alpha level is 1%, then you have a 1% probability of making type 1 error. If you have a 10% alpha level, then you have a 10% probability of making type 1 error. So we can decrease the probability of making type 1 error if we use a smaller significance level. Use 1% instead of 10%. But the trade-off is they're directly related, the probability between type 1 and type 2 error. So as your probability of type 1 error decreases, the probability of type 2 error increases, and vice versa. So if we want to make it more difficult to reject by decreasing the alpha, then we increase the probability of type 2 error that we will not find convincing evidence for the alternative. So in this problem here, if you want to not commit type 1 error, then pick the smaller alpha level. But that means the probability of type 2 error, which I think is worse, increases. So I would pick a higher alpha level here to help prevent type 2 error from occurring.